So far, we have learned about the reliability of a system, how we can use distribution or PDF and hazard rates, reliability, mean time to failure, and so on. But this was for one very simple system. But now we could have multiple systems. So we have a system which is characterized by random variable x, and then you have another system which is characterized by random variable y. Now, if the system is functioning, if both of them are operating well, we consider them like a switch. As soon as this switch is broken, the system is not functioning, or this. So if you put a series, that means that both of them should be functioning. Or sometimes we may have a parallel system. So if either x or y are functioning, then that means that your system is completely okay. Or in some other instances, you may have a standby system and so on. So how we could do that, we see it as interconnected systems. So reliability of interconnected systems, here there are three examples. So if you have a parallel, either system one is has a failure, is like a switch which is opens, that means not working, or the system Y is not has a failure, which means that this switch is opens. Now, if it is parallel, that means that this point is connected to this point. So this random variable Z is like maximum of them. So if both of them are any of them are functioning, that the system is working. So Z for a parallel system, okay, is like maximum of them. So if you have two systems which are interconnected in a way that if either of them are working, you say I define my random variable Z. So you have to consider the distribution of Z for calculating the reliability. In contrast, you could have a series. So in this system, you need both S1 and S2 to have a functioning system. For instance, in surgery, you need a surgeon and you need also electricity. If surgeon fails and is not capable of continuing to do his job, then you need is not working, or if the electricity is out, or if you have any other requirement to do the surgery. So in this case, you need minimum of them. So in the series case, you define a random variable. In some other cases, for instance, in surgery room, you use electricity. This is one system. If the electricity goes off, then you use batteries. So as soon as the electricity goes off, then the battery starts. So while the battery is working, even if this is not working, so in this case, in the standby, so you add the system. So if you have the joint PDF of X and Y for parallel one, which is the maximum, so this area and the red area is the CDF of Z. In the minimum case, the blue area is the CDF of W, and in the standby case, the green area is the CDF of the sum. So obviously, they will have different reliability profiles and different results in this.